Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks again for joining us for another Tuesday live stream. Well, today's topic is a little bit of a departure from our normal content, where we take a deep dive into the technical details of the Horner OCS all-in-one controller, or we take a look at industry topics like Modbus TCP, Ethernet IP, and MQTT. But don't worry, there'll be plenty of acronyms today. Here's today's topic. Today's topic is centered around OEE. OEE is a tool that manufacturers can use to improve their production efficiency. And they can use OEE whether their production processes are fully automatic, fully manual, or anywhere in between. And I'm really pleased to be joined today for our topic by my colleague, Tom Philippek. And I'm going to bring Tom in now. Hey, Tom, how's it going?
Good, Chuck. How are you doing today?
I'm doing terrific. So a little background on Tom. Tom and I have been working together for
25 plus years.
a long time. And something to tell you about Tom, back when OCS first was released as a new concept, the all-in-one controller was a brand new concept, Tom worked for one of our key automation distributors, and he recognized early on the value in that product, and he was a big proponent. And to Tom's credit, over the years, as he's changed positions and he's sold our product directly for Horner or for our distribution partners, in his area, it's really the #1 market share for OCS anywhere in the country. So that's a credit to you, Tom.
Thank you, Chuck.
Okay, so today we're going to be focusing on OEE, and that's really a solutions product. So how did OEE get on the radar at Horner?
So, Chuck, we all get a chance to run around every day and visit our customer sites, and we see a lot of clipboards and white write-on boards and local indication of the status of a cell, a work cell, if it's running or not running, and call for help, call for raw material, which is a little bit of lean manufacturing. We see a lot of these little bits and pieces, and some of the large corporations have gone the full route and got it all in and running, including dashboards in the cloud and so forth. But a lot of them have not. And so as part of the solutions group team at Horner, we've decided that it would be a good idea for us to take and do a pre-programmed solution that take these little bits and pieces of stuff and make it so that customers can easily and quickly get this up and running, collecting data and making good decisions on how to improve their process. And so although people have done this in the past by writing their own with our products, this is our way of attacking to try and help the people that haven't gone that direction yet.
Yeah, and the more ready the solution is for them just to install and configure, the quicker they can start getting good data and taking action to improve their processes.
Correct.
Fantastic. Okay, so we're going to go ahead and dive right into the material. Tom is going to be presenting that material for us today, and I'm going to be your production assistant, but I'm sure I'll chime in from time to time. All right, let's go ahead and get started with the presentation. Okay, it's all yours, Tom.
So on the first slide here, we can see there's a lot of these acronyms out there. And what do they all mean? And how are they different? And which one should I do? Which one shouldn't I do? And there's no real right answer to any of those. They're all very tightly linked and related to one another with different strengths and features of all of them. If you picked one over the other, it may give you some advantages. And I know we promote our product as an OEE product. We are actually much more than just OEE in the way we've implemented this. So as we go through this today, we'll give you some ideas of where we're different. So this is really kind of the start of it, and we'll go through all these features as we go through. So the first question is OEE right for you? And the question to answer is, are you tracking your production data with spreadsheets or white write-on boards? We see a lot of it still out there in the field. And so what's the risk if you're doing this? The risk is that your operators could be entering in the data wrong. They could be cheating the data to make their performance look better. They could have missed writing down mark at a certain period of time. And then at some point, that handwritten data needs to be entered into a spreadsheet, which again creates another level of potential error where it gets entered in wrong. So that all links back into good data. Is it good data? The next question is my production process a manual or automated work cell? So if you're automated, you're probably leaning more towards wanting to do this. But if you've got a completely manual work cell where you're making a product on a workbench and there's nothing automation tied to it. It's somebody building it on their own. That doesn't mean that you shouldn't be collecting this information to determine how you can be better at it. And so the way we've implemented our solutions product, it gives you the ability to do it as a manual solution or an automated solution or as a communication solution. So we have a number of different options on how to do that. The next question is performance visible to the managers? So at that point, in other words, can they see what's happening at individual work cells across the plant floor? And I have this image of the solo cups up here because it is a real one that I saw at a customer site, and I asked them, what's going on with the solo cups? And they said, well, we couldn't implement OEE. It was too expensive. So we just put red, yellow, and green cups out there for them to hang on a pole. And they hang the cup on there, and then we can see across the floor to determine if their work cell is running, not running, or in trouble. So I thought that was a good one for local indication that's non-automated. So we threw that one on there. And then the next question is, do you lack accuracy? In other words, is that data being entered in correctly by the operator? Is it being entered in at a data entry standpoint? Tells you whether it's good data or not. And then at the end of the day, with this data, can you make the appropriate changes to get you good results or be a better manufacturer at what you're trying to produce? So the question, first one is, what is OEE? Overall equipment effectiveness, sometimes also called overall equipment efficiency. So both of them pretty much are the same thing. And this takes a lot of the pieces of all those other acronyms that we threw out there, and it does a complete number calculation. So it takes the availability of the work cell, and that's a goal or a performance goal that you're trying to achieve. And it tells you how close to your goal you're achieving. The second parameter is the performance. That's how many good parts, or how many total parts, I should say. And so the total parts is your performance. And again, there's a goal, a percentage of goal. And then there's a quality parameter, which says how many bad parts or scrap parts. And OEE takes availability, performance, and quality and multiplies all three of them together as a percentage of goal and gives you your total OEE percentage of goal. That's how that works. But it is all based on planned and scheduled production time. The next one that we're going to look at is OOE. Very similar in what it does. It does the same type of calculation, but OOE looks at the planned and unplanned time. So now you've added in component to your percentage of goal for unplanned time. So that is a parameter that sometimes can throw off your total production performance because it's calculating in something that you didn't plan for. TEEP is very similar as well. The only difference with TEEP is that it calculates all time or every time, meaning it's 365, 24/7. So you've got, whether you're running one shift or three shifts, TEEP uses that entire total time calculation. The parameter that you get out of this doesn't tell you as quality. It's a coarser resolution of what you might be doing, but it also tells you what you could be doing that you're not planning on. So there's pros and cons to it, but for the most part, TEEP is only used by people that are doing 365, 24/7 operation. So the next slide we'll talk about is total productive maintenance. And so this is a parameter that really looks at a number of things, and each pillar on that slide talks about what they are. I'm not going to go through all of them, but some of the key ones are looking for process or machine improvement. And again, OEE does that when you get to analyze your data, you get to make choices, but that parameter choice is coming out of TPM type calculations and practices. The other parameter that I feel is really important here is to look at safety and sustained success. So sustained success, meaning how do I get better to be competitive in a global market? So there are three goals of TPM. There's 0 unplanned failures, which is not attainable, 0 production defects, which is not attainable, and 0 accidents, which is not attainable. So at the end of the day, that's what they want to have you come up with, but realistically, you can't make all of them 0. You try and you shoot for the best, but that's really what TPM is all about. There's 6 big losses of TPM, and these 6 big losses are pretty commonly seen out there. unplanned stops, planned stops, small stops, slow cycles, production rejects, and startup rejects. The OEE part of it looks at the availability loss, performance loss, and quality loss as they're related to those 6 big losses. So we've kind of taken those 6 and zeroed them down to 3 in the OEE world. And if you look over on the right-hand side of that slide, it kind of talks a little bit about how they might apply in traditional 6 big losses versus the recommended ones. Lean manufacturing is a parameter or a test that is also called Six Sigma, but it looks at a lot of the same type of things, adds some transportation, some overproduction, unnecessary motion, that type of stuff. But there's a lot of similar ties. The biggest thing that we've pulled from this is the reduced idle time, which is your downtime, reduced defects, which are your scrap parts, and the maximized use of operation staff, which is how do you make changes on your process or your procedure to make everything better. And so that's where the Six Sigma lean manufacturing piece comes in. One of the things that's in lean manufacturing that isn't really spelled out great in this slide is the empowerment of the operator. And the empowerment of the operator is a very important parameter in that a lot of people look at OEE as, is this big brother watching over me? And I think when we presented this at the trade show recently, that was one of the questions that came up. Is that correct, Chuck?
Absolutely. That was definitely a question, is how do you empower the operator and how receptive is the operator to an OEE type system?
So to get operators to buy in and give you the good data that you're truly trying to collect and use here, empowerment is a very key parameter of that. And we've looked at that and implemented quite a bit of that into our product as we move forward with this. And we'll get into that as we move through the presentation today. How does OEE apply to the IIoT, or the Industrial Internet of Things? We all have heard that term technology out there, Industrial Internet of Things, Industry 4.0, all of them tie into that. And it's really the communication, collection of the data, the visualization of the data, and the communication to send the data. And so our OEE plan, and what we're tacking with our product in this, is to go after the collection of that data. Again, your uptime, downtime, good parts, bad parts, and when you're down, why are you down? That's the key. When you're down, why are you down? We want to make the visualization part of it available. And so we make it visually available at the work cell with a tower light and an HMI display. We make it visually available at a plant level with our data collection device. And we make it available at a corporate-wide or multi-plant application through the MQTT push technology, pushing it up for dashboard type applications. So again, plant floor is locally available. Internet connections, we use Modbus TCP for that, and then MQTT for the cloud dashboard level. So why do they need to use OEE? And the bottom line is this: all of us have gotten to the point where we can openly say we're all part of a global economy now. We're no longer competing with our friends down the block with us. It's completely across the world. And so we have to be the best at what we can do in order to compete. Because when it comes to labor rates, we're never going to compete with labor rates overseas. So we better do things better on how we're doing it in order to be able to compete with that level. So that's really the tie of why does manufacturing need to look at OEE. I mean, at the end of the day, we're all looking at the concept of saying, how do we get better at what we do every day, which is an ISO procedure standard and a number of other procedures, which are all looking at continuous improvement. So who needs OEE? There are a number of process and product manufacturing floors out there that need it, but in reality, it's anybody that's looking to collect uptime, downtime, good parts, bad parts. When I'm down, why am I down? And that calculation of availability, production, performance, and quality. So it's available to collect that information and make it available to anybody out there that's looking at this type of information. When we deal with the automation products out there, most of our target customers are at the engineering level, sometimes at the maintenance management level. And so with this product, we're going to be looking at a number of different type of engineering level people. So you're looking at production managers, shift managers, certainly the operators, production engineers, manufacturing engineers, corporate management, and company owners are going to be the ones that are really going to be driving for this type of information to know what's happening at each individual work cell in their facility. So that's who needs to see the OEE piece of what we're collecting here. What to avoid with OEE. So we talked about earlier is the big brother syndrome. We need to make sure that we're looking at this as an analysis downtime tool. So it's going to give us key information on what we can look at and view and improve and fix on the fly. So minimizing those downtimes. So be careful of trying to use one process or one work cell to cover 5 different work cells that are linked to each other. You're better off gauging all 5 of them as opposed to one individually. Make sure that your internal measurements are real, meaning don't pick a parameter that's up high in the sky that you could never achieve on the best day. You want your parameters that you put in to be what I'm really trying to be at my best today, and not what the absolute ideal in the best world scenario that could never be achieved. And then the last thing that I would point out is be careful of using this as a club. Don't use this to beat up on the operators that are using this. Use it as a yardstick to measure your entire process, not specifically the operator. So measure what you're doing. Don't use it as a club to beat people up for what they're not achieving, because it might not be their issue. So what is OEE used for? Again, it's an improvement metric. We're collecting all this information at the work cell. We make it available to the management team. The management team will analyze that data, look at what they feel are the weaknesses of the process and what would be the best possible change to improve that. And then they develop an action plan to go out and implement an action plan. And then you measure, did that action plan have success to improve what we were having an issue with? That's really, at the end of the day, what it's used for is that improvement cycle. And again, it's all about the data that you're pulling in. Good data in is good decisions out. So this one is also the empowerment side of it. We talk a little bit about Big Brother watching over, and in the empowerment of the operators is really an important thing. And what we do that empowers the operator, there are a number of ways for a work cell to be flagged as being down. One of them is an automated process, which means you've exceeded your time cycle, and a grace period that says, yeah, you should have made a part by now and you haven't. Tell me why you're not running. But we've also let the operator go in and they can drive downtime ahead of that. So if they know for a specific reason that they're not going to be able to achieve a cycle or a performance part, then they can go in and flag it down and give the downtime code, which starts that collection of that information faster. So that's an empowerment to the operator to do that. And then the second thing we've put in for empowerment is the ability to call for assistance or call for help. In the system we have, they can do a call for raw materials, a call for maintenance, or a call for supervisor, and all of them are call for help. And so that notification gets sent out and it's data logged, and it gets sent out as an email message to whoever's programmed into the system to receive that message. But we also start an internal timer at that point. That timer runs, and what it does is it gives the person that received that message a time function to acknowledge that they're aware of the call for help. And so if that cycle times out, the system will step up and text or email a message out to the next level of person or the manager above them. And then that person has the chance to time and come out and acknowledge. Acknowledging does not mean that they've cleared the help. They just acknowledges that they got the message. So that all is empowerment to the operator to show, I made a request for help and it took X amount of time for somebody to acknowledge it. And then it took even this time to come clear that help. So that's, again, empowerment to the operator, because it's not pointing at them as to why the machine's not running. They've gone out and said, I've notified somebody to come out and help me because this machine can't run. So how does automation manufacturing help with OEE, meaning the PLC manufacturers? What are they doing out there? Well, we, for many years, were right in the group with everybody else where we've talked about OEE. And at the end of the day, it's all of the PLC people provide the hooks and tools in their software suite, but the customers themselves are going to be the ones that write the code to do it. There are a couple of hardware manufacturers out there who do provide a complete system as part of their solutions teams. And from what I've seen in the PLC world, those people that are doing that are some of the bigger PLC players, and they'll charge anywhere from $20 to $30 to $40,000 for a system that they're going to come in and do for you, and that's per work cell. So it's not inexpensive at all. It's very, very expensive. The software companies, on the flip side, they're the ones that are all about the data. And so they're doing turnkey dashboards and widgets and first pass reports and NRE charges for development, startup, and data management. But really, at the end of the day, what they're about is a monthly charge for the data exchange. So they're going to be looking to get that monthly refundable fee every month. And even though it looks fairly small at the beginning, when it's calculated out over time, it becomes very expensive to go that route. And then the third option is system integrators that are providing a turnkey plug and play on the floor. And in that case, you're going to have some NRE charges for them to do the development to absolutely tweak it to your needs. These will tend to be fairly expensive as well, but at the end of the day, theoretically should be exactly what you're looking for. So how much time and money do you need to use to implement OEE? And I guess it depends on what you chose in the previous slide. It can vary anywhere from $2,500 up to $50,000 per node. And that's, in a hardware and software cost combined. It's a matter of what's going to fit for you and how much time do you want to put your team into doing. And turnkey systems are expensive. Buying the parts or using existing PLCs, picking a software company, getting your IT department involved. Are you going to do just local visualization, or are you really trying to collect the data and get it to shift reports and weekly reports, monthly reports, that type of stuff? So it's really a point of where do you want to take it, how much time can you put in, and how much engineering resources do you want to have your team put into it to achieve. It's the cost of the hardware and the engineering hours that are going to be the calculation of it. Are there monthly fees tied to OEE and MQTT data? As I mentioned earlier, if you're doing a cloud dashboard type through a software company, there will usually be monthly fees tied to it. So moving data via communications through the clouds, depending on who your services are, can have monthly fees tied to them. Push data is a MQTT protocol. That's a MQTT. That's a fairly new protocol out there. And instead of a pulled architecture to get the data, it's a push architecture, meaning the device will push the data when it sees changes and timing and so on and so forth. And so we've got a number of YouTube slides that go through MQTT and how that all works. And so that links into that, but it's built into our OEE solution. Is MQTT easy? I'm going to answer my personal perspective on that is no, only in that it's a IT type of an environment. If you have a strong IT team behind you, it can be very easy to implement. If you're not accustomed to working with IT technology type stuff, it may not be that simple for you to do. So that's $1 million question on that one. Are there standard protocols for MQTT? The answer is yes. There are some standards out there. There's not one, but there are some that have tied through Sparkplug, Ignition, and a few others. And we try to stay current with what we feel is the industry most common. And do you have to use MQTT? And the answer is no, you don't have to. It's going to be depending on whether you want to do multi-plant cloud-based data dashboard type information. If you do, it's a good option, but you still don't have to use MQTT. And there's a lot of other communication options that are out there. So we certainly still have all of our Ethernet connectivity options. There's still OPC. There's all kinds of other protocols and strategies out there to do that type of stuff. So from a visualization standpoint, there's 4 different ways to look at this. The first one is local visualization. And as I mentioned earlier, we're doing this with a tower light that you can see across the plant floor instead of walking right up to the monitor, and also for the operator to be able to see right on the HMI display. So that's local visualization of what's happening at that individual work cell. Our data concentrator device is our plant-wide visibility. Our data concentrator will let us bring in up to 32 work cells into one. and then it publishes that as a web server. And so it gives us the ability to have a number of ways to see that. One is on a plant-wide screen, whatever size monitor or TV screen you want to project that up to, and we can get some pretty large images out there. But more importantly, we have the ability with the WebMI to make that visible at any plant manager's office and on their smartphones, their smart tablets at home. If they're on vacation, they have the ability to visually see that plant-wide information. The bottom two slides get into multi-plant and cloud-based dashboards. So this gets into pushing data out to collect from multiple plant locations. You can then visually see an application where you can drill into the plant, go into a work area, pick a work cell, and then see dashboard information, which is still showing you all of the information we collected on the availability, production, quality, and total OEE, as well as total parts and ideal time, average time, max time, min time. All those kind of things are available as part of the data. So what is MQTT? Again, it's a push protocol, a corporate decision whether they want to get that data to go other. So when we collect it, we're going to store it as a CSV file on our micro SD card. We email that out to managers on the plant floor and within that plant so that they can do report analysis with it, create whatever they need to do with it. But that's strictly going to stay in that plant. It certainly could be forwarded out email-wise to anybody at corporate, so you don't necessarily have to go MQTT to do it. But if you've got multiple plants, more than likely MQTT, clouds, and dashboards are going to be the direction that you're going to want to go. And it's a newer technology that's out there. We tend to be the edge device on this. So if you look at the slide on the bottom, we're collecting information from the work cell. We're an edge device to push it to a broker, and the broker then can position that data out to a SCADA system, a manufacturing execution system, historians, or some other type of database application that they're going to use. How do I use OEE? So this is getting into the calculation of the data and the analysis and action part of it. OEE is all about the collection of the information. That information is going to identify where you're having issues, problems, or not. Maybe it's where you're excelling. And so sometimes it could be downtime codes as to why you're not up in production mode. But when I say sometimes it's in a good mode, you might have 3 work cells that are doing the same thing. Why is one of the 3 work cells outperforming the other ones? So that's the good side of data collection, that you can say, well, let's figure out what we're doing there that's causing that improvement, and we'll figure out how to make it happen at the other 2 cells. Once you've got that information and you've done your analysis, you get to make some decisions. And so this is to determine what your top losses are, or what the biggest downtime reasons are. And so by doing that analysis of that information, you've now zeroed in on if you know what your biggest weakness is, you know what area to go attack. The action part of it is to look at that area and say, well, how can I improve that? And make a manufacturing decision on what you believe can be the best countermeasure to bring that parameter up to your better, more improved goal. And then by implementing those, you at the end are going to be able to go back and start that process over and see, did you get the results that you were looking for? Did it improve the process? Did it make your production information or your production systems more efficient or effective? Where can I use OEE? The better question is, where can't you use OEE? I'm not sure I 100% agree that they're super strong in every one of these areas, but they certainly can be used in each one of these areas. The real line is any manufacturing process, any production facility, whether it be food and beverage, whether it be pharma, medical, anybody that's doing production, anybody that's doing secondary packaging, that type of stuff is all very high targets for the OEE product solutions. What is the ideal OEE solution? So, we talked about at the beginning, clipboards and white write-on boards is what we see a lot out there today. And that is certainly not the ideal. The ideal would be to get this data collected efficiently and fast and get it to people quickly. So in a manual process where it's on a clipboard or right on board, it then gets passed along to somebody to do data entry. That data entry takes time. Once that data entry gets done, it's still got to get forwarded to people. So with our process and our calculation into the micro SD card on our controller, we publish that out as an attachment to an email at the end of the shift. And it's a CSV file, which that image on the top right there shows what that file will look like in raw format. Now, once it's in that format CSV file, you can take that and do whatever you think you want to do with it to create shift reports, weekly reports, monthly reports, whatever it is. And you can do your analysis of your data based on the reports that you're pulling. An OE solution that's fast and easy to implement. That was at the beginning what we said our goal was. We are out to try and achieve something that's quick, easy, and doesn't take a lot of your engineering time to get it up and running. And just as a parameter measurement, some of the sites that I've been out helping with startups on, the first system that we went and did a startup on might have taken 45 minutes to get the first one up and running because there was a lot of explanation of what the individual goal parameters that are being set needed to be. By the time we went through and did it a second or third time, those parameters were down to about 15 minutes to take a system out of the box and have it in an up and running state. And so 15 minutes to take out of the box, no data collection, to have it collecting data on your plant floor is really a pretty impressive number to be able to grab that data that quickly and make it useful. And that's one of the things we were trying to achieve was the quick and easy part of it. And then the second part of it was the cost part of it. So we'll get into that one here in a slide or two, but the easy to implement and fast, what the goal and the plan is there is to reduce the amount of engineering time that our customers need to put into it. So measuring this is done at a number of levels. The first level is the shift operator. And that shift operator is going to be the one that's going to be most in touch with touching this product and using this product on a daily basis. So depending on if it's an automated cell or a manual work cell, they may be using it more in a manual process than they would in an automated process. But if it gets to the point of downtime and selecting downtime codes, everybody's going to be using that touchscreen at that point. Any of the managers are going to be using the tower light for visualization so they can see what's happening. But the operator has that visualization right there, but they also have that empowerment of determining, am I running or not am I running? When we get to the plant level, that's when we get to the data concentrator piece. And so this is going to be plant managers that are going to be looking at this. Manufacturing or production engineers are going to be looking at this. And it's going to give them the ability to have good information in and making the right calculated decisions on how to make effective changes out on the floor. But it's really that plant visualization, that plant data collection, and that plant overall positioning on where they're at.
Okay, thanks, Tom. Now, basically, if we take a look at the solutions that we offer, and while we're not going to talk specific prices or anything, here's the solutions that we're offering. Now, we've got a variety of what we're calling, I guess, panel-based solutions. We have panel-based solutions where we've got the touchscreen, where all the configuration is done and all the interaction with the operator is done. Obviously, those panel solutions come with the light tower to provide the feedback across the plant floor. And we have UL and non-UL versions of those. That's correct?
Correct.
Okay, very good. And then, like you said, when you're talking about beyond the work cell level, when you want to take a look at things from maybe a plant management level across multiple workstations, that's where our data concentrator solution comes into play, right?
That's correct.
Right, so that utilizes WebMI, and therefore, if you utilize WebMI for that function with that concentrator, then your plant manager, your production control people, they can effectively log into a web page and see at any moment the status of what's going on in the floor. And if you decided to, as a company, to make the extra effort to go ahead and, hang a 70-inch television from the ceiling and, connect it up to WebMI, now you would have a display almost like an and-on out on a plant floor that anybody could look at.
That's correct.
Right. Okay, very good. And then obviously we're not talking price here, but earlier in the presentation, I think you said that, the range is anywhere from $2,500 to $50,000 per workstation, depending on the total solution, those sorts of things. Rest assured, our solution's at the lower end of that.
Yeah, we're definitely on the lower side of that curve, for sure.
All right, very good. So if you're interested in any of these solutions, you can get more information at hornersolutions.com. We've got sales literature available, of course, if you want to hand that to a colleague to have them take a look at that. And of course, you can always freeze this frame, and those are the part numbers for the current OEE-based solutions. I'm going to go ahead and bring Tom Filipek back in here. So Tom, thanks for that excellent presentation. A lot of good information there. My takeaway was that just about any manufacturer, no matter how small, no matter how automated or non-automated their processes are, should be looking at OEE as a tool for improvement.
Absolutely. And not only the OEE piece, Chuck, but the empowerment as part of the TPM, the lean manufacturing, which is always about continuous improvement. Six Sigma quality is also in this system. And then, the Industry 4.0, moving data up and communicating data, those all are part of this as well. So, I know we're promoting it as OEE, but it's a whole lot more than that.
Right. That's really great. Now, we did cover our solution a little bit today. Obviously, the primary goal of today's presentation was to really inform people about OEE and some of the other manufacturing terms they'll run into and why they should really take a look at it. But if you have anybody out there who is interested in more technical details on our solution, where can they go for that?
So we've got a number of YouTube channel videos that we've done. One of them is on our product and how it would be visualized to the operator. What do they see? How do they move around? How do they handle calls and downtimes, that type of thing. And then there's another YouTube video that gets into the setup and configuration of an OEE box of ours. The key point to that is that our product, the way it is written, nobody ever does any programming in ladder code. It's just all a parameter setup of their production information. So it's all done through the front screen of the controller, but there's YouTube videos on both of those.
Terrific.
In addition to that, Chuck, we would also, if anybody wants to see these live, all they need to do is reach out to us. We'd be happy to do either virtual live presentations or on-site visits.
Terrific. All right. Well, great presentation, Tom, and thanks for joining me today.
Thank you.
All right. So once again, I'll remind you, if you haven't done so already, please subscribe to our channel. We're closing in on about 1,000 subscribers, which is a big change from where we started, obviously, just about a year or two ago. And if you haven't subscribed, go ahead and do that and choose notifications, because if you do that, then you'll be notified every time we post a new video or every time we go live. Okay, so until I see you again next week, Tuesday at 2 o'clock, let's all get out there and do us some good.